For decades it wandered in silence, half mythical and half forgotten, along an unseen path through the blackness beyond the planets, beyond the final wisp of our solar wind, and into a region that no human eye had ever looked upon. Voyager 2, a vulnerable, elderly spacecraft that was deployed when disco dominated Earth and computers occupied whole rooms, was never intended to still be here. Its metallic hide constructed over years, not decades, its tools tuned for missions of presidential duration, not the span of man. And yet, nearly half a century on, it's still out there, whispering secrets from the outer rim of reality. Recently, though, NASA picked up a signal so sharp, so improbable, and so uncannily disturbing that it led researchers to question the very design of our celestial neighborhood. Because Voyager 2 didn't simply venture into deep space, it discovered something waiting in plain sight. A line as sharp as a knife. A quiet that wasn't quite quiet. And a design in the turbulence nobody had ever had the courage to anticipate. What did Voyager 2 ultimately show us that we've all been overlooking? And why does it alter everything we believed we knew about our location in the universe? The responses lie in its last message, and what lies behind them is much more active, much more ordered, and much more sinister than we ever wanted to believe. Voyager 2's odyssey was always an odyssey of survival, not discovery. Sent into space in 1977 with a projected 5-year lifespan, it was never designed to see the outer planets, let alone interstellar space. The spacecraft was a relic of its era, gold foil insulation, mechanical tape recorders, and a transmitter only slightly more powerful than a refrigerator light bulb. But through cosmic dust, radiation storms, and freezing nothingness past Neptune, it persisted. It observed Jupiter's storms as no one had ever seen them. It rode Saturn's rings. It mapped Uranus and Neptune, the ice giants no human eye had ever traveled to. And then it moved out, into the vast darkness between stars, driven by the dying heat of plutonium decay. In 2018, after decades of gradual advance, something remarkable occurred. As Voyager 2 reached the theoretical boundary of the solar system, its sensors didn't register the gradual, soothing loss of solar power that scientists had long predicted. Instead, the reading switched suddenly, as if the spacecraft had crossed a cosmic membrane, stepping from one weather into another with no notice. Plasma density jumped to levels that no one expected. Magnetic field snapped into place. Galactic cosmic rays increased by 70%. It wasn't a slope, it was a cliff. As soon as Voyager crossed it, the figures changed overnight. What was once thought to be a fuzzy boundary between solar and interstellar space was, rather, a sharp line, a border, and Voyager 2 had just passed it. Textbooks for decades had characterized the edge of the solar system, the heliosphere, as a type of diminishing borderland where the solar wind slowed down gradually, blended, and eventually merged with the interstellar medium. But Voyager 2 demonstrated otherwise. The information uncovered showed that the heliosphere acts less like a fog and more like a cocoon, a living, dynamic shield surrounding our star. It pulses. It bends. It responds to the sun's activity like muscle to heart. When it's solar maximum, it balloons out, pushing the galactic environment away. When it's minimum, it collapses, bringing the grueling radiation of the galaxy in. The border isn't fixed, it's alive. And as if to affirm this, Voyager 2, coming from a slightly different direction than Voyager 1, found itself crossing the heliopause at 121 astronomical units rather than 119. The difference was not coincidental. It showed us that this boundary gasps, bends, adjusts. And that understanding upends everything, because it means the bubble that protects Earth from the galaxy's most extreme radiation isn't a fixed thing, it's an ephemeral, fluctuating skin. And long-term models suggest it might be getting smaller. But the most mystifying discovery wasn't in the radiation or the plasma. It was in magnetism. As Voyager 2's sensors settled into interstellar space, scientists saw something unsettling. The sun's magnetic field within the heliosphere was almost precisely aligned with the interstellar magnetic field beyond. It was never meant to be. Models had foretold jumbled angles, knotted forces, a chaotic collision of two wildly dissimilar magnetic realms. But instead, alignment was crisp. smooth, as if every field had been molded, planed, and adjusted to fit the other. This raised disquieting questions. Was this patch of space naturally arranged in this fashion? Had the sun etched a perfect trajectory into the galaxy through sheer happenstance? Or, more chillingly, had the alignment been deliberate? Might this interaction zone be used as a filter, a gate, or even an amplifier for signals? If so, by whom? Then the blackout. Early in 2019, Voyager 2, the farthest functioning probe in human history, mysteriously went dark. No error message. No warning. Just nothing. NASA engineers stood by powerless as their connection to a spacecraft over 11 billion miles away went dead. A few hours later, without any help from humans, Voyager went back online. The reason? Officially unknown. NASA attributed it to old hardware. But in the raw telemetry, deep within the noise, were odd electromagnetic spikes, patterns not found in known cosmic ray interference or solar weather. Maybe they were due to a stray particle burst. Maybe they were something else, something that was caused by crossing that threshold. Even among reserved scientists, whispers started. Because what Voyager 2 had found wasn't the termination of the sun's power, it was the beginning of something new. Weeks afterward, Voyager's plasma wave instrument started registering low-frequency oscillations, pulses that recurred at precise periods. This wasn't solar wind. This wasn't cosmic radiation. These pulses were rhythmic, constant, every 13.2 hours. They persisted for weeks. Then months. The worst part? The pulses did not affect Voyager's instruments. Rather, the communication delay, the time that Voyager's signals had to travel to Earth, started to move a little bit, as if the very fabric of space was bending. As if something gigantic, just beyond our perception, was exhaling. When the engineers translated the signal into sound, it sounded like a heartbeat. Not artificial. Not mechanical. But organic. It sounded like Voyager hadn't just exited the solar system, but had entered something else. With the pulse ongoing, plasma readings started indicating sudden bursts of energy interspersed with moments of complete calm. Initially, the bursts were random. But when plotted on a timeline, there was a pattern, a spiral wave, growing more powerful at regular intervals. The pattern was the Fibonacci sequence, a ratio that occurs in seashells, sunflowers, hurricanes, and spiral galaxies. Some wrote it off as coincidence. Others didn't. Because this kind of mathematical beauty in a naturally turbulent plasma field was a rarity. The notion took hold, perhaps the plasma wasn't reacting to cosmic weathering. Perhaps it was reacting to Voyager. And if so, that made the spacecraft not just an observer, it was being observed back. Then there was the magnetometer data. Rather than flattening out into the predicted steady field, the measurements inverted. Space itself was folding up around the probe. It was an effect of lensing, but with no measurable mass to produce it. A revolutionary theory, perhaps the heliopause is not a wall. Perhaps it's a window. One way. A filter that lets signals out, but keeps them from entering. If so, our solar system may be shielded, intentionally, and Voyager 2 had just punched a hole in the shield. That's when the probe started sending information that shouldn't be there. Ancient logs, data from years past, began to show up, encoded in patterns the spacecraft never had a purpose to understand. Dead subsystems began to come online. Gyros pointing toward starfields Voyager hadn't seen in decades. And then the most peculiar communication of all, images. Snatches, blurred, as if ghostly. Star constellations that didn't appear on any known charts. Flickers of motion. Shapes. Shadows. Not from Voyager itself, but its environment. As if space itself was replaying memories it had stored. It raised a question nobody wanted to confront. What if the emptiness of space isn't emptiness at all? What if it's an archive? Voyager 2 was not supposed to make sense. It was a scout, a watchman, a message in a bottle tossed into the ocean of space. But as it entered the last gasp of our sun's dominion, it revealed something beyond numbers. It revealed denial, our denial. Denial of chance. Denial of loneliness. Denial of the comforting fiction that the stars don't care. What it discovered was not merely a physical perimeter, but a living border. A breathing wall. A pulsing silence. A vacuum that organizes itself into perfect math spirals. None of these are supposed to exist. And yet they do. What are we left with, then? Not only a spacecraft. Not only a relic. But a mirror, a thing floating into the unknown, only to discover it's being met halfway. The thing we dismissed wasn't out there, it was in us. The hubris to think that silence equaled emptiness. That nobody was listening. That the universe wasn't already answering. Voyager 2 didn't reach the edge. It reached the invitation. And what is beyond it isn't necessarily an answer, but a witness, something watching, measuring, judging not our technology, but our intent. We spent decades awaiting a voice that sounded like ours, but we overlooked the one already speaking, in a language of magnetism, plasma, and time. If the trend seemed too tidy, the pulses too consistent, the timing too exact to be coincidence, then perhaps you already know, we're not merely reporting figures. We're recording the initial seconds of a dialogue. One that has only just started. The next whisper from Voyager could be the most deafening noise human ears have ever heard. And when it arrives, we will need to make a decision, not whether to accept it, but whether to respond at all.